This is incredibly difficult. This is the first time that there's ever been a rocket where that is possible. That's what makes Starship so profound.
Have you ever wondered why SpaceX catches its giant Starship rocket in midair? It looks incredibly cool every time you see it, but it also seems extremely risky. If just one thing goes wrong, the whole thing could turn into a very expensive disaster. So why did SpaceX choose to do it anyway? Why take the risk of attempting something no one has ever done before, especially when the company has already mastered a highly reliable method of reusing its Falcon 9 rockets? This is the truth behind SpaceX's mid-air catch. Okay, first we need to answer a pretty basic question. Why does SpaceX go through all the trouble of catching Starship with giant mechanical arms or landing Falcon 9 boosters back on Earth in the first place? After all, it would be a lot simpler to just let them crash into the ocean and build new ones every time. That's how most rockets have operated for decades. The answer comes down to one word: reusability. SpaceX believes reusability is the key breakthrough needed to make life multiplanetary and to scale civilization beyond the limits of a single planet.
You simply cannot ascend the Kardashev scale unless you have a reusable spacecraft, and you cannot extend life to the moon, to Mars, and to the rest of the solar system without a reusable rocket. The cost is simply prohibitive. You can't make enough rockets. Yeah. Unless you can refly them. Just like any other mode of transport, you can imagine that if we had to throw away airplanes every time we flew, flying would be far too expensive, and basically no one would be flying airplanes.
The idea that every other form of transportation is reusable, so rockets should be reusable too, is actually a pretty convincing argument. However, if it were easy, it would have been done a long time ago. The challenge is that rockets have to operate in one of the harshest environments imaginable. Earth has a deep gravity well and a thick atmosphere, which makes achieving reusability incredibly difficult. In many ways, those factors make it barely possible. Over the years, there have been numerous attempts to develop fully reusable rockets, but most of those programs were abandoned before reaching their goals, because the teams involved ultimately concluded that success wasn't achievable with the technology and resources available at the time. The Starship launch system consists of two main parts: the Super Heavy booster and the Starship spacecraft sitting on top of it. Unlike most rockets in history, both are designed to be rapidly reusable. In other words, they need to come back in one piece and be ready to fly again really quickly. Now, a reasonable question is, why not just recover Super Heavy the same way Falcon 9 does? Imagine a future where Super Heavy is equipped with giant deployable landing legs, essentially a much larger version of Falcon 9's system. After separating from Starship, the booster would perform a boost-back burn, steer itself using grid fins during re-entry, and then fire its center Raptor engines for a final landing burn. As it approaches the ground, several massive landing legs would unfold and lock into place. The booster would gently touch down on a landing pad or a drone ship at sea, with shock absorbers helping cushion the impact. The engines would shut down, and the vehicle would stand upright on its own legs, looking very much like a giant Falcon 9. Sounds pretty straightforward, right? The problem is what happens next. Once the booster lands, crews would need to secure the vehicle, vent remaining propellants, inspect it for damage, and prepare it for transport. If it landed on a drone ship, the vessel would then need to spend days traveling back to port. After that, the booster would likely have to be moved horizontally due to its enormous size, transported to a processing facility, lifted upright again, and finally placed back onto the launch mount before another Starship could be stacked on top. That's already a lot of extra work. But the biggest problem isn't the operations, it's the legs themselves. A Falcon 9 booster has an empty mass of roughly 25 to 30 tons. Super Heavy, on the other hand, is expected to weigh well over 200 tons when empty. Building landing legs capable of supporting that kind of weight, surviving repeated landings, absorbing impact forces, and deploying reliably every single flight would require an enormous amount of hardware. And rockets absolutely hate extra weight. Those giant legs could easily add tens of tons of dry mass once you include the structural reinforcements, hydraulic systems deployment mechanisms, and shock absorbers. Every kilogram added to the booster is a kilogram that can't be used for payload or propellant. It's one of the cruel realities of the rocket equation. A little extra weight can have a surprisingly large impact on performance. Then there's the turnaround problem. SpaceX isn't trying to make Starship reusable in the traditional sense. They're trying to make it operate more like an aircraft. Ideally, a booster returns to the launch site, gets inspected, refueled, and flies again as quickly as possible. Landing on legs would add multiple handling and transportation steps, slowing everything down. That is not rapidly reusable.
In order to achieve full reusability, everything's got to be perfect. The engines, the structure, the avionics, the choice of propellant. You've got to go to extreme measures for mass optimization, which is why we have the tower catch the rocket instead of putting on landing legs, which are heavy. The rocket can simply be caught by the tower. And we haven't achieved full reusability yet, but we do expect to achieve that hopefully later this year with Starship. And then you've got to achieve full reusability. Then you've got to go a step beyond that, which is make it rapidly reusable, such that the rocket lands, it gets caught by the tower, gets put back on the launch stand, and can be flown again without any refurbishment or laborious inspection, like an aircraft.
Yeah.
So while giant landing legs would probably work, SpaceX looked at all the trade-offs and came up with something much stranger. Don't carry landing legs at all. Instead, let the launch tower catch the booster directly out of the sky. The first time Elon Musk proposed the idea, a lot of people thought it sounded completely ridiculous. And honestly, it's hard to blame them. Catching a 70-meter-tall rocket with giant mechanical arms sounds less like aerospace engineering and more like something you'd see in a science fiction movie. Until SpaceX actually did it. On October 13, 2024, during Starship Flight 5, the company turned one of its wildest ideas into reality. Less than 3 minutes after liftoff, the Super Heavy booster separated from Starship and began its journey back to Earth. Climbing to nearly 96 kilometers in altitude, the booster flipped around and prepared for re-entry. As it fell back toward Texas, it accelerated to tremendous speeds before firing its engines to slow itself down. Just minutes later, it punched back through the exhaust trail it had created on the way up. About 1 kilometer above the ground, 13 Raptor engines ignited simultaneously, rapidly bleeding off speed. Moments later, 10 of those engines shut down, leaving only the 3 center Raptors running for the final landing phase. The giant booster carefully guided itself toward the launch tower. Engine plumes swiveled back and forth as the vehicle made tiny corrections, almost like a balancing pencil standing on its tip. Descending at a slight angle, it aligned itself with the tower and slowed to a near hover. Then came the moment everyone was waiting for. The giant chopstick arms of the launch tower, known as Mechazilla, remained wide open until the final seconds. As the booster settled into position, the arms slowly closed around special catch points near the top of the vehicle, gently capturing it out of the air just 7 minutes after launch. Suddenly, one of the craziest ideas in modern rocketry didn't seem so crazy anymore. Ironically, the biggest challenge wasn't making the arm strong enough. Holding the weight of the booster is relatively straightforward from an engineering perspective. The hard part was everything else. The arms needed to move with incredible precision, absorb energy smoothly, avoid damaging the rocket, and gently capture a vehicle descending from the edge of space without scraping, crushing, or destabilizing it. That's an astonishingly difficult control problem. But the payoff is enormous. By catching the booster, SpaceX eliminates the need for massive landing legs entirely. That saves a huge amount of weight, which can instead be used for additional propellant or payload. More payload means more satellites, larger space stations, more equipment for the Moon and Mars, and ultimately a greater ability to build infrastructure beyond Earth. When you run the numbers, the trade-off starts making a lot of sense. Instead of carrying around tens of tons of landing hardware on every flight, let the tower do the work. And perhaps most importantly, catching the booster opens the door to something SpaceX cares about even more than payload: rapid reusability. In the future, a captured booster could theoretically be lowered directly onto the launch mount, inspected, refueled, stacked with another Starship, and prepared for another flight, far faster than a rocket that needs to be transported, lifted, and repositioned after landing. That's the real goal. As SpaceX keeps pushing the Starship program forward, it's also finding new ways to make the catch process simpler, lighter, and more reliable. The goal hasn't changed: catch the booster directly with the launch tower, and get it ready to fly again as quickly as possible. But the hardware involved is already starting to evolve. With Starship V3, also known as Block 3, SpaceX is introducing several changes to the Super Heavy booster that could significantly affect how Mechazilla catches it. Earlier versions of the booster relied on dedicated catch fittings mounted near the top of the vehicle. These hard points were specifically designed for the chopstick arms to grab during recovery. V3 takes a very different approach. Instead of carrying separate catch hardware, the booster's 3 grid fins are expected to do double duty. The fins are roughly 50% larger than before, positioned lower on the vehicle and arranged in a new 90-90-180 degree configuration. More importantly, they are designed to handle the structural loads of both lifting and catching. In other words, the same fins that help steer the booster through the atmosphere may now also serve as the points where Mechazilla grabs it. It's a clever idea when you think about it. If a component is already there, why add extra hardware that only gets used for a few seconds at the end of a flight? Every kilogram saved on the booster is another kilogram that can be used somewhere else. SpaceX seems to be applying its favorite engineering philosophy once again. The best part is no part.
The tower itself is changing too. The chopstick arms planned for Pad 2 are expected to be shorter than the original versions. That might sound like a downgrade, but shorter arms can move faster, react more quickly, and track the descending booster more precisely during the final moments before capture.
The overall catch sequence remains mostly the same. The booster still performs its return burn, slows itself down, and carefully approaches the tower. But now, alignment becomes even more important. Since the chopsticks will be interacting directly with the grid fins rather than dedicated catch pins, the booster must arrive in exactly the right orientation. There's a lot less room for error when your steering surfaces are also your landing gear. It's another example of SpaceX's constant obsession with simplification. The rocket isn't just learning how to fly back anymore. It's learning how to become easier to catch every single time.